Last time you weren't able to see the text, so I'm going to try this zoom in feature and we'll see how well it works. The map below shows the locations of earthquakes and volcanoes on the Earth's surface. Today, many of the world's most active volcanoes are located around the edges of the Pacific Ocean and are often referred to as the Ring of Fire. You may notice that both volcanoes and earthquakes tend to be concentrated in particular areas. The theory of plate tectonics helps explain this pattern. You can see there the challenge. How does the theory of plate tectonics help to explain the location of earthquakes, volcanoes, and mountain ranges? So as you're reading today, you're going to be using Student Sheet 45.1. Plate tectonics is the theory that the Earth's lithosphere is broken into plates that are in constant motion. The edges of these plates may be sliding past each other, spreading apart, or colliding. Over geological time, important processes, such as the formation of mountain ranges, earthquakes, and volcanoes, takes place along the boundaries where these plates meet. Sliding plates. Geologists call the region where two plates are sliding past each other a transform boundary. Earthquakes are common along transform boundaries. There is a lot of pressure between the plates as they try to move past each other, and this pressure is only released when large pieces of rock along the boundary crack or shift their position. People can sometimes feel the vibrations caused by these movements and call them earthquakes. In Activity 44, Mapping Plates, you recorded the overall movement of several large plates. Each plate may have different types of boundaries along different parts of its edge. A transform boundary is located between a part of the Pacific Plate and a part of the North American Plate along the western edge of California. This is also known for its many earthquakes, as you can see in Figure 1. Map of recent earthquakes and volcanoes on Earth. On its eastern edge, the North American Plate has a divergent boundary. So if you go back up to Figure 1, which is this, you can see what they're talking about. Here is the eastern side of North America, the western side of North America, and they were talking about a divergent plate being on one of those boundaries. Remember which one? Back down to the reading. Spreading plates. The place where plates are spreading apart is called a divergent boundary. Volcanoes, as well as earthquakes, are common along divergent boundaries. As the plates pull apart, the lithosphere thins and molten magma from the Earth's mantle erupts onto the surface, forming new lithosphere. That's down here below. You can see the new lithosphere being created. Over time, the lava from these volcanoes can build up and form volcanic mountains. You read about such mountains in Activity 38, beneath the Earth's surface. Sometimes divergent boundaries are located under the ocean, and large underwater volcanic mountains can form. The plate boundaries seen along the middle of the Atlantic Ocean are an example of an underwater divergent boundary. Take a few minutes to look at this diagram that's here, talking about the convergent plate boundary over here and the divergent plate boundary in the middle and the transform plate boundary. Notice the arrows that they've used in their illustration to show the movements of the plates. Back out a little bit and go down to the next page. Here is colliding plates. Colliding plates create convergent boundaries. What happens along a convergent boundary depends on the type of lithosphere at the edge of each of the colliding plates. The Earth's lithosphere, which includes the crust and solid upper mantle, varies over the surface of the Earth. This is partly due to differences in the thickness of the Earth's crust. The crust that makes up the oceans is generally thinner than the crust that makes up the continents. Ocean crust is usually about 10 kilometers thick, while continental crust ranges from 20 to 80 kilometers thick. For this reason, the lithosphere is about 100 to 150 kilometers thick under the oceans, and up to 300 kilometers thick at some continents. Despite being thinner, oceanic lithosphere is denser than continental lithosphere because its crust is made up of denser rocks such as basalt. Remember the black basalt that we passed around in class? When continental and oceanic lithosphere collide, the less dense continental lithosphere usually rides up over the oceanic lithosphere, which goes down into the mantle and is destroyed. You can see that in figure 2 if you go back and look at the picture. The process of one plate moving below another plate is known as subduction. Both earthquakes and volcanoes are common along subduction zones. The volcanic mountains that you plotted along the western coast of South America in Activity 44 are a result of the oceanic lithosphere of the Pacific Plate being subducted below the continental lithosphere of the South American Plate. Subduction also occurs when two sections of oceanic lithosphere collide. When two sections of continental lithosphere collide, the lithosphere tends to crumple and be pushed upward, forming mountains as well as causing earthquakes. The Himalayan mountains found along the northern border of India were formed when the Indian plate collided with the Eurasian plate. Several of the world's highest mountains, including Mount Everest, are part of the Himalayas and were formed from this collision. Moving down to hotspots. Most earthquakes and volcanoes occur along plate boundaries, but there are some exceptions. For example, the Hawaiian Islands are located in the middle of the Pacific Plate, yet each Hawaiian island was formed by a volcano, as lava from ongoing eruptions built up into an island. A hotspot is a fixed area of the mantle that is so hot that magma rises through the lithosphere above it. As plates move, the location of the hotspot remains the same. In time, the movement of the plate can result in a chain of volcanic mountains or islands, like the Hawaiian Islands. Look down at that figure down below. Scientists use this information to help determine the direction of plate movement. Today, only the island of Hawaii, also called the Big Island, has an active volcano. At its southeastern corner, the next Hawaiian island, called Loihai, is already forming. It is still completely covered with seawater, but its top is almost 2 kilometers high above the ocean floor. Scientists predict that it will build up enough to rise above the ocean's surface in about 1 million years. I wonder if I'll be around to see that. Maybe you guys will be. So here are the analysis questions. You'll talk about those with your group when you get finished with the reading. Make sure that you go back, do the work that you need to do on the worksheet, take your time and do your best. Let me see if my zoom out works. Ooh, zoom in, zoom out. Have a good day.